Now that we have seen many examples on statement and decision coverage, let's see a real practical example in a programming language. And here we chose Python because Python is very simple. You just look at the code and it is very easy to understand it because Python is a high-level language. So let's understand this example first and begin to apply statement and decision coverage on it, and let's see whether we can find defects inside this code or not. So here, for example, number equals 7. Here I have a number and I want the user to guess this number. I will ask him to guess what the number is. The number is 7. If he enters 7, so this is a correct answer. If he enters any other number, this is a wrong answer. So here I will get the input from the user. I will put it in an integer because this is an integer 7, and put it in a variable which is user number. If user number equals my number 7, then I will print the message you guessed correctly, else I'll print another message which is wrong answer. So let's first begin with statement coverage. So in statement coverage we have one if statement, this if user input equal y. Of course, in my development environment this is easier. You find all your statements appearing in this way, so this makes the code easier to analyze and understand. So inside this if statement we have another if statement. So if the user input is y, okay, and the number is correct, he will print you guessed correctly. So I can have this as the first test case. So let's run it. For example, here enter y. If you want to play, I will say y. Guess what the number is? So in this case I will say, for example, 5. No, we said 7 in order for the system to print you guessed correctly. So here he told me you guessed correctly. So this is the first test case and it passed through all this section. The only section that needs another test case is this else statement. So here I will run the code again and say, for example, yes, I want to play, and the number is 5. Wrong answer. Okay, so this is statement coverage. It did not find any defects. But I can find some defects by statement coverage if I think of my inputs in another way. For example, here he says enter y. So I might think, okay, the user might enter the value of y in uppercase. So this is uppercase y. It is very small, but I have written it in uppercase. So if I write uppercase y, nothing happens. Why nothing happens? Because here in this code, the only accepted character is small y, okay, lowercase y. So how do I solve this? I might do something easy. If the user enters the value of y, whether it is uppercase or lowercase, I will convert it into a lowercase y. And then I will check, is the input a lowercase y or not? So here we have two conditions, okay, or two inputs. Uppercase y, it will be converted into lowercase y, and in this case, the person will enter the game. If it is a lowercase y, so this is also a correct value, and also the person will enter the game. So here, using only statement coverage, I could find a defect in this code. So to solve this defect, I will say lower. What is lower? In this case, I will get the input from the user, whether it is lowercase or uppercase, and I will convert it into lowercase. So here, if I run the code, if I write lowercase y, here I enter the game. If I write also uppercase y, like you see, here I also entered the game. So this is an advantage of statement coverage. Of course, if I perform decision coverage from the beginning, I'll find this defect. But what if I want to use decision coverage? So here I have this if statement, and it has two decision outcomes. The user input is y or any other character. So this will need two test cases. But this test case in which the user input is y has two decision outcomes. So here I will need three test cases. The first, the user input is y and the number is guessed correctly. The second, the user input is y and the number is not guessed correctly, it is a wrong number. And the third test case, the user input is any other character other than y. So the first two test cases we have already tested. The first is y, and we say correct number, okay, you guessed correctly. The second is also y and a wrong guess. So he says wrong answer, and the third, any character other than Y. So for example, T. So here, none of the decision outcomes have been executed. But here we should think of this code. Would it be a good thing that the user doesn't have any message appealing to him telling him that he is not going to participate in the game? So for example, imagine this as a touch screen. You have yes and no. If you press yes, you will enter the game. If you press no, at least he should tell you that you have left the game, or at least he redirects you to another game, for example. So in this case, we should care about this else statement. So this else is connected to this if, okay? So here we can say else print choose another game, for example. So here we designed a new path for this user, the user who declined to participate in our game. So here we can say, no, I don't want to participate. Here I'd say choose another game. I might also think, okay, let's say else if user input equal no. Okay, choose another game, else print please enter Y or N. So here I added more scenarios to my code. I say if it is yes, he will enter the game. If he says no, I will ask him to choose another game. If he enters any other value, I will tell him that this value is not valid. I can say this is an invalid input. Please enter Y or N. So here if I run and I say anything, okay, this is an invalid input. Please enter Y or N. So this was a very simple example on statement and decision coverage in a practical way that will help you while you are writing your code, so that you make sure that all the scenarios that the user might go through are covered in your test cases.